In the last video, we looked at truth tables, and then specifically 3 of the 5 basic ones. We looked at negations, conjunctions, and disjunctions. In this video, we'll look at 2 more, conditionals and biconditionals. So conditionals are if-then statements. Let's look at an example. How about if it is spring, then the grass is growing. Or then grass grows. So the first part of the statement is P, it is spring, and then the second part, the grass grows, is Q. Alright, so there are, again, 4 different possibilities for the true and false values for P and Q. Okay, so it could be spring, in 2 cases, and then either the grass is growing or it's not. And then if it is not spring, then the grass could be growing or not. Alright, so now let's look at this if-then statement and decide in which of these 4 cases it's considered to be true and in which it's considered to be false. Alright, so if P is true, if it is spring, and the grass is not growing, and then we make this statement, if it's spring, then grass grows, is that true or, oh, I'm sorry, actually we want to see if these are both true. Okay, so if it is spring and the grass is growing, and I say, if it's spring then the grass grows, okay, then that would be a true statement. What if it is spring and the grass is not growing, but I say if it's spring then the grass is growing? Well, in that case, then that's a lie. Okay, so I've said under these conditions the second thing is going to happen, and yet it's not, so therefore what I've said is false. Now, what if it is not spring? Then is this true or false? Well, if it's not spring and the grass is growing, I can't really say that this is a lie. I can't say that it's false because it's not even spring. So there's no way to really verify. So a lot of times with these if-then statements, we'll say like if it's not false, then we consider it to be true, right? So let's say that it's summer, and I say if it's spring, then the grass grows. Well, I have no evidence to say that that's a false statement because we're in a totally different season, and maybe the grass is growing in summer, but that doesn't have anything to do with the statement. So we would say that the statement is still true. And then if it's not spring and the grass is not growing, okay, so maybe it's winter and the grass isn't growing, then that doesn't mean that this statement's a lie. It just means I wasn't really speaking to the situation right now. Okay, so I'm making a different sort of a statement. So in that case, we would also say that this is still a true statement. All right, so really the only time when a conditional statement is false is if all of the conditions have been met and yet the conclusion is not true. Right? So I've promised something. I've said if it's spring, then the grass grows, but if it's not, then that would be a false statement. Another example would be, let's say if I'm not busy Friday, then I will go to the movies, and then Friday comes and you're not busy, and your friend comes and says, all right, you ready to go to the movies? And if you just don't feel like going and you say, no, I'm not going to go, well, then your previous statement was a lie, because you said if you weren't busy on Friday, then you would go. Okay, so now we look at a biconditional, and this is the most complicated of them, because when you see this symbol, P with the double arrow, Q, this means if P, then Q, and if Q, then P. So we're actually making 2 if-then statements. So So let's say that my statement is tomorrow is Saturday if and only if today is Friday. And we have this abbreviation, IFF, and that means if and only if. So tomorrow is Saturday if and only if today is Friday. Okay. So what I'm really saying is if tomorrow is Saturday, then today is Friday. And I'm also saying if today is Friday, then tomorrow is Saturday. All right, so we start out with the same four possibilities. Either tomorrow is Saturday or it's not, and then either today is Friday or it's not in both of those cases. All right, so let's look at the case when tomorrow is Saturday and today is Friday. Okay, so now I'm going to use my work on this previous table. So I know that the only time if P then Q is false is if P is true and Q is false. All right. So if I just, like if this had just said if P then Q, then I would be able to go through, and the only case in which this would be false would be this one here. Right? And then we put this off to the side. That's false. Right? And then the rest would be true. So I'd have true, true, and true. Now I also need to say, I need to look at Q, if Q then P. So I'm going to read this backwards, right? So I'm checking to see, is it true if today is Friday, then tomorrow is Saturday, right? So I'm going to look at these letters in the truth table backwards. Okay, so I'm going to look at Q first, TF, TF, and then P, true, true, false, false, right? And then I want to see if when is if Q then P, when is that false, right? So again, the only time when that would be false is if Q is true but P is false. The hypothesis is true but the conclusion is false, right? Or in other words, if today is Friday but tomorrow is not Saturday, even though that doesn't make sense, then this would be a lie, right? So for this one, I would have true, true, false, true. Okay, and then now I want to look at P if and only if Q. So remember I said that means if P then Q and if Q then P. Right? So go back to what we learned about conjunctions. When are these and statements true? Only if both of these two things are true. So I'm going to look at these two lists I just made for my two statements, and I want to see in which situations are they both true. Right? So they are in the first case both true. In the second case here, one's false and one's true, so this would be false. In the third case, this would be false. And in the fourth case, these are both true. Alright, so what we can see from this table is that there are only two cases in which a biconditional is true, either if the hypothesis and conclusion are both true, or if the hypothesis and conclusion are both false. So I think maybe what would be useful is to look at another example, because the last statement was, well, we know that was a true statement, so it would be nice to look at something that may be true or may be false. So let's go with the statement, well, we talked about the movies already, so I will go to the movies. Oops. I will go to the movies if and only if my, let's see, I am done studying. Okay, so keep in mind what that means. That means if I go to the movies, then I am done studying. And if I am done studying, then I will go to the movies. Okay, so both of those things go together. All right, so let's say that you do go to the movies and you are done studying, well, then that would be a true statement. Right? And let's say that you don't go to the movies, but you are not done studying, well, then this is still a true statement because you said you would only go to the movies if you were done studying and vice versa. All right. However, if you make that statement, and let's say you do go to the movies, but you're not done studying, then that's a lie because you said you would only go if you were done studying. And vice versa, if you don't go, but you are done studying, that's also a lie, okay, because you said if you were done studying, then you would definitely go, and you didn't. All right, so we have two cases in which that's a true statement, and two cases in which that's a false statement. Okay, so armed with those 5 basic truth tables, what we can now do is go on and make truth tables for any compound statement at all. So you probably want to have those completed truth tables on hand as we go through some of these next examples.